Up to this point, the work I've been doing with this Lattice iCE40 has been with this PCB that I put together, and it supports an HX4K, and specifically the package is the TQ144, which is a QFP144 package. And things are going fine with that board. Actually, I've been quite happy with the results. I recently posted that I've got some VGA output coming out of this, and that's a good step in the right direction for me. But what I want to eventually get to, if I can, there is a 256 ball BGA version of both the HX4K and 8K. But I'd like to get to that 8K and have it in this BGA-256 package. I've not worked with BGA in the past, so I have some learning to do there. So I thought I would start with something that's maybe in between, which is going to be this board here. And so I put this board together, and this is supporting an HX4K, but the package is a BGA-121. So it's a 121 ball BGA package, and I can either run the HX 8K or 4K. I think there's packages for both, and basically, or versions of both in this BGA-121. So I'll be using that, and I also am trying a new power setup. The one on the left here is just using 3 simple linear regulators to give me my 3 volt, my 1.2, and my 2.5. This one over here is going to leverage an LT3504 regulator, and I think that's more of a buck style regulator, so should be more capable and better than what I have over here. And it also gives me some support to better sequence the way the power rails come on, and it's new to me, so I'm going to experiment with that. The regulator will sit here, and then there's some diodes and inductors that I also need to place on this, and I'll bring power in up here. And I'm going to, out of that regulator, bring out a 5 volt, a 1.2, a 3.3, and a 2.5, and I suppose that means I probably need to come in with a 7 or 8 volt maybe on the incoming part of this. So I'm going to start with that and just try to get the power running, and if that works, then maybe in the next video, what I'll do is I'll come back and do just some loads, some artificial loads that I'll place onto those outputs and see how it responds, and just make sure that it looks like it's working as intended. If I get that far, then I'm going to give a shot at soldering in this BGA, and that is a tiny package, and 121 solder points on that as I go to solder that in. So that should be interesting to see if I can pull that off or not, or if I have difficulties doing that. I have maybe 2 ways. I can maybe use the hot air station that I've got to solder that on. I also have a hot plate that I can warm it up with from underneath, or I have an IR oven I could try. So I might experiment with both and see how that goes for me. But I want to get that put together. Maybe one thing you will notice, the finishes on these look different. This is just the standard finish from JLC PCB when I order my PCBs, and you can kind of see it has this silvery look to it. This one looks more copperish, and this is that enig finish. So it was recommended that if you get into BGAs, for the flatness and consistency of this surface, this is better to use this enig finish, if I'm pronouncing that correctly, but to use that finish on this board. So this looks a little bit different, so if you see that and can pick that up on the camera, that would be why. The stuff I've done on this board over here on the left, as far as connecting it in the flash, that should all be the same on this other one, the same types of jumpers. I only put one of the standard headers over here just to do basic testing, so if I can eventually get to where this is populated, I can program it and I can output a test pattern on a little LED bank here. That would probably be a win for this board. But then from there, I have these plugs that will go to additional boards on whichever side here. And that's where I could add in things like a VGA circuit or whatever it might be that I want to do as far as connecting into this FPGA itself. Now, to support all that, I've got a box of goodies in here, and maybe I'll just switch cameras here. And I ordered up a bunch of stuff. me just pull out all of this and let's see what we've got here. So as I get into this, looks like I've got myself, I tried to order up all the parts I'll need for this board here. But here I've got a Schottky diode, or diodes, that will go on there. This is the actual FPGA itself, so this should be my very small FPGA that's going to go on here. And then this is another Schottky diode. I think I've got two different styles, and actually in the reference material for the power, there were a couple, so I've got both ordered up just to be safe. And I've probably got a bunch of different inductors in here. So here's one inductor. It's a 3.3 microhenry. This is a 4.7. This is my regulator, or should be my regulators themselves. And yeah, this is the LT3504. And then I have a 6.2 microhenry, a 10 microhenry. This is some flash, so these are just new. And I've been using this W25Q128JV SIM, and that's the same one that I have on this previous board that I built, and that's working well, so I'm going to stick with that. Here's a slightly different 10 microhenry and 8.2, a different 3.3, a 4.7 microhenry, a different 10 microhenry, a different 4.2, a 6.2, another 10. This is a different style, I think, of a 10 microhenry, another 10, and some of these, and it could be these in here, are a different package. And that's not them. Those are the same style. And then I have another Zener diode there, another Zener diode, and Schottky. So somewhere in here, I think I do have, there's a slightly different inductor that isn't this style. And hopefully I didn't forget to order it, and it's in here somewhere. There we go. So this would be a little bit different style. Probably can't see these yet, but you'll see them later. These are a tiny little, I don't even know what the package is, maybe an 0805 type of package or an 0603. But small little package that is one of the inductors I need that is different than these other inductors. And I did notice that after I was ordering all the parts, so I probably am going to have a little bit of a challenge, or something I'm going to have to fix on here. So on this board, 4 of these are probably the right footprint, and 1 of these is the wrong footprint. So I've got a larger footprint, and I actually need to use one of these tiny guys, or some other alternative that I can find that will support the frequency and the current, I believe, are a couple of the things I need to make sure get supported there. So we'll see what I end up doing with that, if I try to make one of these work, or if I need to pick a different inductor that maybe will get the job done. So I have some experimenting to do. In the future revisions of this board, I imagine I'm going to tweak some of that, but we'll see what I learn here in this video here, and as I'm putting this together. But I should have a variety of inductors. I think I know which inductor values I'm going to use already, but I'll probably go through and just double check calculations on that. And if something isn't working, I have some choices. I could swap things out. But I'm going to pause here and get this part assembled and see what that might look like. So fast forward, I do have the upper corner of this assembled now, and I can apply power, and I am getting the proper voltages out of the 4 rails. So that so far seems okay. I did not have, I put in a footprint for a 0603 surface mount capacitor for all 4 of these rails to go to ground. And 2 of them take 10 microfarads, and I had those, and the others are spec'd as a 22. I didn't have any 22 0603 surface mount, so for now I just put on some capacitors there. And in the process, I managed to damage a pad, so I just ran that ground over here, which is fine for this initial testing. Something else I noticed I had incorrect in my schematic. There is a power good signal on this LT3504, and I was thinking for some reason that when it went high, it could drive an LED, through a resistor to ground. But as I went back and looked at the data sheet, I had that backwards. It's an open collector output, which, if I understand that correctly, means that when power is good, that goes high, and it basically opens up a circuit. So I need to pull from power, let's say 5 volt, into the LED, out of the LED into the resistor into the power good, and the power good will take it down to ground. That's my understanding of that as an open collector output. And of course, I have turned the LED around, so I am going from 5 volt or 3 volt, I've tried both, into the positive side of the LED, out of the LED on the negative side to the resistor to the power good signal. So I'm missing something there. I don't know why that's not working out. The LED will flash when I turn it on, and I can look at the scope and see that it is pulling, basically that has activated, and it is indicating power good. But I would like to have an LED that lights up with that. So I must be missing something really basic and probably pretty obvious to someone that's watching this. But if you have any ideas on that, let me know. I have tried different sizes or values, I should say, of resistors, and I have tried a couple of different LEDs. This LED should run with just a couple of volts to it easily, but it's not working for some reason. Again, I can turn it on, the LED will flash, but then it goes out, and if I measure, I do have voltage before and after it, and I see the voltage drop on the LED, it's just not lighting up. So I don't know if there's a current limitation possibly, and maybe if I did want an LED, I would need an external transistor. I don't know if that's a possibility, that there just isn't enough current pull capability inside of the LT3502. It doesn't sound right, but I don't know what else to try at this point. So if anybody has ideas on that, let me know. So I think this is good enough for now. I think what I do need to do in the meantime is probably order up some of these 22 microfarad 0603s. If I can find those, I assume I can find those. And if not, maybe find some 0805s or something that I can make work for now. And in the future, I need to just make a bigger footprint and maybe go to a 0805 for these 4 capacitors that are going from the rail to ground, or maybe even a little bit bigger than that, just to give myself some flexibility in capacitors. And then I need to swap this around for the power good, maybe add in a transistor if that's what it's going to take. And maybe I could try that here. I could just put a little transistor above this and see if I could make that work. So maybe that's a possibility. So I'll do more testing with that later, unless someone has an idea of what I'm missing. And then I did, before I got into assembling this, I did comment that I have an inductor here that is a much smaller package than the footprint. So I just put in a little wire bridge to connect that from the pad, tiny little wire to the inductor, and then the same on the other side. And that seems to be working perfectly fine. And then I have all these resistors that help me, kind of dial in the voltage. It almost would be nice to have 4 little trim pots that I could use to really dial in what the output voltage is, because there's one of these that I actually had to swap because it wasn't quite dialed in quite the way I wanted to see it. And I did also have to adjust another resistor that I had mislabeled in my parts and had a wrong value in it. The frequency was running at, maybe 100 kilohertz instead of megahertz is what this should be running at, which it is now. It's running at maybe not quite a megahertz, just a little bit underneath that. But so far, so good on this. I will sometime this week or coming weekend maybe put a load on the rails, at least the 3 I care about, the 5 volt, the 1.2, and the 3.3, and then just see how it performs. If if it misbehaves, I guess, when I get power really pulling from it, current pulling from it, or not. So, end of the day, seems to be working so far. And like I said, the only issue so far is how I wired up this power good, which maybe isn't a big deal. I think a lot of people probably just leave that disconnected anyways, which is what I'll do for now. But it would be nice to have a little LED indicator showing that power is good. Obviously, I can also add LEDs. I've got LEDs over here for 3.3 volt, 5 volt, 2.5 volt, and also a 1.2 down here. And I don't know if I can actually get those all to light up. Maybe I'll try that here real quick. I'll put a really small resistor and a 1.2 here. I'll see if I can put these on. And let me just try that here real quick. Okay, so I've quickly put in 4 LEDs, 4 red ones, and 220 ohm resistors on all 4. So I've got one for the 5 volt. That's the brightest one. The next brightest is the 3 volt, and then the 2 5 volt, and then the 1.2 doesn't light up, and I think it's just there's not enough voltage to light up that LED. So I've got all 4 rails working. I have these indicators, which is good enough so that when I turn this off and I turn it on, if those 3 light up, that tells me that I've got those rails running fine. I will probably on the next revision add a transistor so I can light up the 1.2 rail. And like I said, I need to figure out how I get the power good to show up. And maybe that's also an external transistor that'll take care of that. But I'll have to dig into that more. Okay, some days I'm a little slow. Real quick editing note as I go through this. I did, I think, track down the cause of why my LED wasn't lighting up or staying lit as part of this power good signal. And initially in my schematic, I was thinking that the LT3504 would actually drive the LED, and I would want to take the LED to a resistor to ground, and that was wrong. And then after that, I was thinking that actually the LT3504, when power was good, would actually complete a circuit and allow me to take, let's say, a 3.3 volt into my LED to a resistor to ground. And I was a little off there too, not surprising. But what I think I actually finally figured out, I'm a little slow today, that I was connected on the wrong side of the resistor, and basically I was trying to hook up the LED on the resistor further away from the LT3504 on the opposite side of the resistor that went to 3.3 volt. Instead, I should have had the LED connected on the inside of that resistor on the side close to the LT3504. And in the data sheet for that, they do show where you should be pulling the power good signal. And my previous comments in this video, I was on the opposite side of a resistor that I should have been. Anyways, long story short, what you see here is that working correctly, I believe. So I'm pulling from 3.3 volt into a resistor. That resistor on the other side connects to the power good signal on the LT3504. Then my LED and its inline resistor have to be on the inner side or the left side of that resistor on my PCB here. And earlier I was trying to test it on the right side of it instead of the left side of that resistor, which doesn't work because basically when power is bad, it's pulling it to ground. So the easiest way for the current to flow is to go through that ground instead of through the resistor and LED. So LED won't turn on. When power is good, the LT3504, I believe, just takes power good to a high Z state, not actually pulling it up and not pulling it down, just basically disconnecting high Z. And once it does that, then the current's going to flow from the 3.3 volt through that inline resistor to get to the power good location signal where that's at. Then it'll go down through this resistor out through the LED to ground. Hopefully that made sense, but I think I've got that sorted now. So now as I do turn on the system, I am getting a proper power good LED lit up, and I think I've got that straight. So if any of you are watching this and that still doesn't sound right, do let me know. But I think I just simply
Initially misunderstood the output of the pin, of that power good pin, and then my follow-up to that, as I was thinking through this video earlier, I was just simply connecting my resistor LED to the wrong side of that other inline resistor. So in the next video, what I'll do is I'll get a load on all the rails, at least the 3.3, the 1.2, and the 5.0 rails. I really don't care much about, or I'm not too concerned with the 2.5 rail at the moment, but I'll test out the others and just see if I start pulling some current through that, if things look okay or not. And if that checks out okay, then the next step will be for me to try to get the BGA installed.